Innovations in flood mitigation, such as AI-driven early warning systems, permeable surfaces, and automated tidal gates, become crucial for neutralizing the threat of floods before they reach a point of no return. According to the Department of Statistics of Malaysia, in 2024 alone, flood-related losses reached a staggering 933.4 million ringgit, with the nation receiving roughly 990 billion cubic meters of annual rainfall. Effective water management is critical. By investing in these technologies now, we move from repairing destroyed infrastructure to preventing it, effectively destroying the threat before it can manifest into a full-blown economic crisis. Like the saying, it is better to prepare and prevent than it is to repair and repent. Ultimately, the push for anti-flood innovation is a push for a better future. By mastering our water management today, we protect the livelihoods of everyday Malaysians and ensure that the new normal does not dictate the limits of our nation's growth. My project is designed to reduce the impact of flooding by introducing practical solutions that manage floodwater effectively and sustainably, while buying valuable time to develop long-term strategies that can prevent flood losses altogether. The adaptive urban flood retention system is made up of 3 chambers. The first chamber is made up of several angled baffle plates, which force the water to snake around obstacles, reducing velocity and slowing larger particles. This protects downstream components and prepares the water for sedimentation, which is important for the next step of the process, where the larger particles or sediments will travel across a wide slope basin where it will slowly settle at the sediment trap. This is to make the maintenance process much easier, as all the sediments are already piled together and only need to be scooped out. Afterwards, the water will gradually make its way to the pipe, where it will be redirected to the third and final chamber. In the third chamber, there is a multi-stage flow regulator. Water passes through outlets of increasing size: a small bottom hole, a medium middle hole, and a large top hole. The multi-stage flow regulator automatically adjusts discharge based on water level, allowing higher outflow during extreme floods without manual intervention. The main function of this is to reduce the peak flood discharge, which, to put into simpler terms, is to stop a sudden rush of floodwater from damaging roads and buildings. And finally, after the water has gone through all 3 chambers, the filtered water will be discharged into nearby rivers or oceans, where I'm sure the marine wildlife will appreciate the clean water. Together, the chambers reduce peak flood discharge and make the system low maintenance and self-regulating. That is the full process of which the flood water will go through. However, if the curious few are wondering how I got these conclusions, you may look at the following panels, explaining how I got these numbers using formulas, with a small explanation in each paragraph. You can pause the video here to read the full explanation. The overall impact that this project brings is create an accessible and affordable alternative to complex flood regulation systems while maintaining similar levels of efficiency, even if it is less robust. This would reduce the cost of building flood management infrastructure, making protection more widely available, especially for communities with limited resources. As a result, it could help minimize property damage, improve public safety, and reduce the environmental impact of floods. The adaptive urban flood retention system demonstrates a theoretically effective method for reducing peak urban flood discharge through passive methods and with minimal moving parts. By increasing cross-sectional area and placing baffle plates, the system reduces flow velocity by an astounding 87.5%, significantly improving sediment settling efficiency. The slope sedimentation basin enhances maintenance practicality by collecting pollutants and sediments in a trap. Overall, the system offers a scalable, low-maintenance, and cost-efficient solution for mitigating the effects of floods around urban environments. I'd like to thank you for your attention and thank you for watching all the way to the end of the video.